the next method we would like to add? Exactly, remove an element from a particular location. So instead of removing from the particular location, another thing we can do potentially, and we're going to do it, is that what we did exactly on the linked list. We first implement our search method, right? So finding a particular element in the list, right? And then we can also use that, right? So it's kind of like, okay, now I have this particular element in the list. Let me remove it now that you find it. So maybe our search method can return the index, like some of you suggested last time also about the linked list. So what if the link, the search method is passing us the value? So we can implement that here. It's not easy, it's not hard to do that. But we're going to implement a search method here that is going to find a particular value or key inside our array. And then, again, if you have duplication, imagine we don't have duplication. Well, in case we have duplication, it's going to find the very first one and return it. That's a simple search, right? So we're going to return the index to that one. So again, in order to do that, what we have to do, of course, we have to, linear search, right? So we have to just go through all the elements one by one, and it's going to start from the index 0. So that's what we basically going to do. We could also use that other method that we know, the for each, right? So to do that, because we're not really going to change anything in this list, we're just going to read it. So we're going to start from there, and we're going to go all the way to the size, and we're going to search, right? So how we're going to, where's the I? So that means I have to now go to every single element from the index 0, and then I'm going to do the comparison. So again, keep that in mind, since everything is string, we know that the string method has the string class has the equal method in it. To compare, we're going to use that equal. So making sure, because again, keep that in mind, the string is a reference type, and you're comparing reference with equal, sign like this. Then that means you're basically comparing only the addresses, right? Which can go wrong, right? So we don't want to do that. We really want to compare the contents. So that means we have to use the equals method. So we're checking the equals method, and if we find that this is going to return true, then we're going to return the value of this index, right? So that means we find that, and we're going to return. Otherwise, if we get out of this loop and we get into this return right here, what does that mean? We couldn't find it, right? So if we couldn't find it, we're going to now decide that we're going to just return -1. That means the index that we know for sure we're never going to have an index -1. So if you get an index -1 from our search, we know that this element was not in the list. So any negative value that returned, that can tell us that this particular element was not in this list. So any question about our search method? So what is the, again, complexity of the search method? Order up, and exactly. Any objection about that? Again, if you have an element in worst case scenario in this list, going to, again, linear search, right? So it's going to exactly act like in the linear search, which is going to be the worst case scenario for it is going to be order n. Okay, another thing we like to do before we start implementing our remove method is writing a method that's giving us an element in a particular location, right? So I'm going to give it an index. Right, and it's going to return that. It's a pretty simple way to implement it in the array list, right? What I have to do, just have to return it, right? Of course, you want to make sure that this index is not out of range. And this is how we know if the index is not out of range, right? So I'm just going to copy that. But this one definitely has to be not size itself. And so if it is, then we're going to return that. If not, I'm just going to return null in this case. Any problem with that? It's obvious, right? We go to particular index and we're going to return it. How long that one? What is the complexity of this one? Just go to that index and return it. What is the complexity of it? 1, right? Everybody agree? Don't do anything specific in order to find that element. So now we're ready to do our remove. So first remove that we're going to implement is going to be the remove method that is going to remove a particular elements maybe from the list. Right, so we're looking for a particular element and we're trying to remove it. So since we already have our search method here, it's going to help us a little bit, right? Our search method returning an index of that method, of that index, if it's find it. So we can actually use that, right? So we're going to now use that index value of this by using our search method. Of course, if it return -1, what does that mean? That means this is not in this list. We can tell the user that. That this element is not in this list, right? So the key that you're trying to remove you could potentially do that in here too, right? So well, we're probably going to use this locally only. Okay, so but if it's in the list now, we'd like to remove it. So when I find that I want to remove it, basically I'm trying to remove it from any index. It can be anywhere, right? So we have the index of it. So it's not like always any index of the last one. And so that means I have to find that index and then I have to do the shifting again, right? So we want to make sure that if it's index 0, for example, we have to make that null and then we have to shift everything back to the index 0. So that's also going to take us in worst case scenario order of n, right? So that's a potential order of n scenario, and that's kind of like removing element from the beginning of the list. And that's going to act as an order of. So let's implement that. So similar to basically what we do in the remove, I like to have a temporary location that I can store that. I mean, we already know what is the value, of course, so maybe I don't even have to do that really, and I just have to shift everything, right? Because we know it's going to be the key. That's something that we already know. We just have to do the shifting. So now the shifting is going to happen inside a loop. I already know it's going to be within our capacity, right? Because otherwise we wouldn't be able to find it and remove it. And I know that's not going to be the last one as well, because I mean it can be the last one because we're also accepting the size. So we're going to start from the size -1, and then we're going to shift everything back, right? We have to do the stuff from size -1, right? Or we're going to the size it's okay. Now we have to actually we have to shift everything this way. So probably if the value of index is 0, then I have to get the index plus 1 and then put it here. So that's what we're going to do all the way to get to the size -1, the last element. So that's how we're going to do it. So we're going to implement this integer. I guess yeah, okay, perfect. The index plus 1. Just want to make sure. And then we're going to go all the way to the size. Okay, of course. And this one is I plus plus. No, sorry, yeah, but K plus plus. So that's when we're going to shift everything back. So in order to do that, then it's going to be list K minus 1. Okay. And so we're going to basically shift them right from the end to the beginning. And then automatically it's going to be removed right from that index because we're overriding it with the value of index plus 1 right there in this loop. So we don't have to make sure it's null or anything like that. And the only thing after I'm done here I have to do is to make sure I'm going to decrease the size. So and also in case of the shrinking is necessary. So what basically we have right here is going to be copied here as well. And then also same thing, right? If I want to make sure that the user know what is the element that they removed, I can give them this message of what is actually got removed. So we can also switch this, okay, as you can see easily to a particular index, right? So we can rewrite it in a way that is going to get a particular index and remove. How we can do that actually? Let's implement that because we already have everything for it, right? So what if I implement a method called we have everything for it, right? So how are we going to do that? Can you think about it? Do you like to have the duplication?
It would be best to remove the key all remove the index, but you could just take the code out of remove string.
Why not doing that? Why not what you just suggest? We'll just do that, right? We already know what is going to be the value in that index, right? So we're just passing to the search for the key. So it's going to remove it, right? So or remove with the key. It's going to remove. We just have to make sure it's not empty, or basically the range is correct. Yes.
If you have duplication, then you have a problem.
I mean, again, we decided that our removes, our search is only going to find the very first one and remove it.
Right. What I'm saying is, if I pass the index of the second one, then you take that element, you pass it to search. It's going to find and remove the first one.
Oh, if you have the duplication, yeah, that's the only. Yeah, that's true. That's the only probably. It's basically going to work only if we don't have we have a set. We don't have any duplications, Yeah, but so basically, if as your friend said, we don't have duplication. So you know the difference between a set and an array, right? So set doesn't have any duplication. It lets you to add duplication. So everything else is going to be the same. It just don't let you to have a duplication. If we know we don't have duplication, that would be one way to do that. So again, we're not going to go through this. But again, one of the things I want you to practice on it, how you can have a method, implement a method to go through all this list and remove all notations from the list, right? So I want you to practice on that, right? So at least maybe you can call this remove duplications, and then you implement it yourself. So no index. As I call it as a to-do for you guys, as a practice, right? You won't have no duplication. What we have to do? So how you implement that? It's actually also an interview question. Usually interview question related to array is going to be like, how we can find the duplication, those kind of things. I know the class and we're done. Basically, we had all the methods that we want for the next class. I'm just going to test it real quick. So I want to be able to remove element from the particular location. And then we're good. I'm just going to do one of them. And then I do search. Automatically the search is going to be applied there, right? So if I want to be able to remove E, then good. And I know already this resize definitely going to work. So I'm going to just run this and see if everything working. So as you see, I had this E at the beginning. I removed it. Everything shifts. So if I remove another one, just to be safe, I want to make sure that the resize is working too. So I'm going to remove D as well. And then you see that the resize didn't work yet. And another one. Just want to make sure the resize is working. So see, I should make the resize happening. Yes. So we